My name is Ian Smith. I am a PhD student at the University of Maryland, and I am a 2023 IFER graduate fellow. My funded project focuses on creating a small microfluidic device that replicates the in vivo tumor microenvironment in vitro to study how mechanistic changes occur during the initiation of metastasis to eventually lead to a reduction in animal models. When I was first applying to PhD programs, I wanted to do vascular engineering, so studying how we can create vascular constructs for tissue engineering. Unfortunately, my dad was diagnosed with stage 4 pancreatic cancer right around this time, and so my focus switched from vascular engineering to cancer engineering. So the Stroka Lab has been committed to conducting rigorous research on cancer without the use of animal models. They do this primarily by creating in vitro microfluidic devices that replicate in vivo cues from the microenvironment to study how those affect cancer behaviors. I, of course, wanted to be special and create my own device that replicated a cue that had never really been studied before. In my first year, when I was talking to another faculty member about the different cues that cancers experience when they're undergoing metastasis, we landed on improvisation because it was a completely understudied field because it's really hard to visualize it in vivo. So I created a device that allows for the observation of cancer and then combining my previous interest in vascular engineering in proximity with an endothelial vessel to see how the two interact with each other during this complex process. The microfluidic device was named the Spheroid Associated Angiogenic Vascularization System, also called the SAVS. With the SAVS, the spheroids are cultured in proximity to the endothelial vessel, and we can see them starting to invade towards each other, and this allows for the mechanistic observation of interactions that are not able to be studied in vivo. So with the support of this fellowship, I will further validate the SAVs to ensure that the cues that we're seeing here in our device are similar to the ones that we're seeing in vivo, so what we're actually seeing is translatable. And on top of that, we're going to try to provide novel observations, so actually observing this cue of cancer improvisation into these endothelial vessels and seeing how cancer is manipulating these vessels to spread them apart so it can spread throughout the body. With the support, we hope to reduce the number of animal models. We have a collaborator here at University of Maryland, and they've already opted to use this device over a traditional in vivo model to study how their proposed therapeutic is going to reduce cancer angiogenesis. So we hope to continue this in the future, and we're able to do this through the support of IFER. So thank you.